In this video, we have an exponential equation that we want to solve. So in this one, we have three exponentials. One with base 5, one with base 7, and one with base 35. Now, if you have just two and they're isolated, you could solve it real easy by just taking the natural log or the log 20 base. In this case, it's not going to work. So let's see if we can use some algebra here. We have 5 to the 2x. I'm going to bring this over to this side. Changes the sign. So it's minus 2 times 35 to the x power. And then I'll have the plus 7 to the 2x equal to 0. And then I'm going to rewrite this. I can write this first term here, 5 to the x quantity squared. The 35, I can write it as 5 times 7. That's still to the x power. And then this is going to be plus 7 to the x quantity squared is equal to 0. So notice if I have a minus b quantity squared, that's going to be the same thing as a squared minus 2ab plus b squared. And then to make it a little bit more obvious here, this is 5 to the x then, squared minus 2. And I can break this up. I have a product here to the x power, so I can also write this as 5 to the x times 7 to the x. And then this one stays the same. And notice this is like an a here, a b here. So this would be a squared, b squared, and then minus 2, and then the 5 to the x again, that's your a, and 7 to the x is b. So it kind of fits this right here. So this can actually be factored out. It's a perfect square here. So this would be the same thing as 5 to the x minus 7 to the x. In other words, we're given something like this, a squared minus 2ab plus b squared, and we simply write it as a square of a binomial. In this case, 5 to the x minus 7 to the x, and this is equal to 0. And of course, this is squared here. This squared will give me that. So let's just take the square root here. Square root of both sides. Since we have a square on the left side, gives me 5 to the x minus 7 to the x. And the square root of 0 is 0. So then we have 5 to the x. Adding 7 to the x to both sides, I get 5 to the x equals 7 to the x. Now from here you should be able to figure the answer, but let's say you didn't see it here. Normally we have an exponential on one side isolated, another one on the other side. We just take the natural log or log of both sides. So here I'm going to say let's take the natural log of both sides. The base really doesn't matter at this point. You can use base 2, base 10, whatever. The more popular ones would be base 10 or natural log. So this will be this, like this. Then properties of logs allows them to bring this exponent as a coefficient, so this will be x. Natural log of 5. The same thing here, x can be a coefficient. So I'm going to bring this to the front, and then bring this term over, so this will be minus x. Natural log of 7 equal to 0. So again, properties of logs allows me to bring that exponent as a coefficient. The same thing for this one. So I'm going to get x natural log of 5 on this side, x natural log of 7, and I just put this term over, change the sign. And then I'm going to factor an x out of these two here. I'll bring it over here, so this will be x, and this will be ln 5 minus ln of 7 equals 0. Now at this point, this is just a number, and it's not 0. Ln of 5 minus ln of 7 is not going to be 0, so I can divide both sides by that. So divide both sides by this. On the left side, this will just give me an x. On the right side, 0 divided by this number is just going to be 0. So the answer to this is x equal to 0. Now here, we should have figured that out, because 5 to the x equals 7 to the x. There's no way that can be equal unless x is 0. But if you don't see it, you can go through the process here. And you can check this out here. Put a 0 where the x is here. That can be 5 to the 0, that's 1. Put a 0 here. That gives me 7 to the 0, that's 1. Does that equal 2? 0 here, 35 to the 0 is 1 times 2 is 2. So that checks out. Thanks for watching. We'll see you next time.